Good morning. Today we need to finish up with section 19.3 and take some notes on how you locate the epicenter of an earthquake. So I've got my notebook here, and that is what I'm going to put at the top of the page. 19.3 Epicenter Location. Let's just put down a couple of facts about how you find the epicenter first, and then we're going to draw a picture to kind of represent those facts. So, to find the epicenter of an earthquake, you need to know the lag time between the S and the P waves. So use the lag time, and remember that's the difference in the arrival times between the P wave and the S wave. So use the lag time between the P and S waves and the travel time curve, and that was that graph that was in your chapter copy, to find the distance to the epicenter. So you look at the line for the P wave and the line for the S wave, and you try to match up the space between them to the lag time that you were given. Once you know the distance to the epicenter, then you take that distance and draw a circle with that distance as its radius. And then you need to repeat that for two other recording stations. Anywhere that you have a seismometer placed on planet Earth, that's known as a recording station. So you need data or information from 3 different stations in order to plot the epicenter of your earthquake. And when we're going to draw a little picture down here next, you'll see why we need that data. So we need 3 recording stations in order to draw the epicenter of the earthquake. So let's say, for example, here is station 1. And I'm just going to sketch a circle for station 1. We're going to assume that this was the distance to the epicenter for station 1. That's a pretty terrible circle. That's okay. Whatever this radius is, that was how far away it was from the epicenter. So that means the epicenter could have been at any of the points along this circle. At least it would be if I had a better circle. Then, if you have another station, like over here, we're going to call this station number 2, and this is going to be pretty far from the epicenter, so I'm going to only have part of a circle here for station 2. Guess I could finish it up here. Again, that's kind of a terrible circle. But what you see here is that when you only have 2 stations, and again, this distance would be how far the station was from the earthquake. So the earthquake could have taken place at any of these points along the circle. But when you have 2 stations, your earthquake could have been at this intersection point, or it could have been at this intersection point. And you don't know which one with only 2 stations of information. You have to have at least 3 stations to have your epicenter pinpointed. And I'm sure, by the way, I'm drawing this picture, you guys can predict where the epicenter is going to be. So I'm going to cheat a little bit on this one because I'm just making a sketch here. Oh dear, my circles are just getting worse. Oh well. Hopefully yours look better than mine. But this would be the epicenter location right here. When you get an intersection from all three stations, that's where you know where your epicenter was. So you have to have at least 3 stations, because if you only have 2, then you get 2 points or 2 possible locations for your epicenter. So let's write that down next. You have to have, must have 3 stations. 2 stations gives 2 possible locations. And remember what that looked like. When we had 2 circles, and that's all we had 2 possible points for that epicenter. The epicenter could have been here, or the epicenter could have been here. So 2 possible locations. That's why you have to have a 3rd station. Need a 3rd circle to narrow choices to 1 point. If you don't have that 3rd station, you can't make a decision on where your epicenter truly was, because you have 2 possibilities. You can also use your arrival times to help you figure out where the epicenter was. So we'll put that here. Arrival times can also be used to determine the time the earthquake occurred. All of this information is connected. The lag time, the arrival time, the epicenter location, and when the earthquake occurred. So it's kind of like a math problem. If you have, 2 of those 3 or 4 pieces of information, you can use those 2. And you can use any combination of those things to pinpoint your epicenter. So you need to know something about where the earthquake arrived in different locations, or when the earthquake arrived in different locations, and then you can kind of work from there. There was a little bit more to the end of section 19.3, and that talked about seismic belts. So it's a little bit different than epicenter location, but it kind of took all of the epicenter locations and put them into 2 main categories. So we're going to start off with the fact that earthquakes are not randomly distributed. They don't just happen in totally random places. In fact, 80% of earthquakes happen on the circum-Pacific belt. Otherwise known as the Ring of Fire. So around the world, where you have a lot of those volcanoes that we learned about last chapter, you also have 80% of the world's earthquakes. Kind of makes you wonder why people live there. This is because those areas are where we find most of our subduction zones, places where one plate is being subducted under another plate, And of course that causes a lot of friction, which melts the rock, makes magma, makes your volcanoes, and it also causes a lot of earthquakes because you have movement of the Earth's plates at those places. 15% of Earth's earthquakes, so 15% of earthquakes happen on the Mediterranean, Asian belt. So this would be like around the Mediterranean Sea, like where Italy is, you have Mount Vesuvius there. These places are also subduction zones. So again, you have those plate movements that can cause earthquakes. So 80 plus 15, 95% of the world's earthquakes occur on one of these two belts. So earthquakes that happen in the middle of plates, like the one that we're going to learn about that happened in southern Illinois and Missouri, are a very small percentage of the Earth's earthquakes. Most of them happen in very predictable locations. All right, that is it for today. Carry on at home, and if you have questions about anything, feel free to shoot me an email.